All right, here's warm up number 23. So we're going to find the coordinates of point P after reflections over different lines. Okay, so when you're reflecting over a line, it's important to graph the line that we're reflecting over. I mean, it's not necessarily required, especially if it's an X or Y axis, but it's a good idea. So let's go ahead and do that. So the Y axis is right here, right? I'm just going to graph these lines first. X-axis is going to be right here, okay? And then y equals x, you can think about that in slope-intercept form. That would be the same thing, right? Because 1 over 1 is just 1. All right, so my y-intercept is 0, and then I have a slope of 1 over 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Or you could go down 1 to the left 1. So what we're going to get with this line is a diagonal line that goes through the origin, like so. Okay. All right. And then finally, we're reflecting over the line x equals 4. Okay. So a lot of times I'll see people graph x equals 4 like this, but it's actually going to look like this. Okay. So x equals lines are always vertical. Now, if you forget, just make up some different points that have an x coordinate of 4. You can put in anything you want for y. I'm just going to put some nice round easy numbers, right? And if I start plotting those, all of those have x equals 4. So I've got 4, 0, 4, 1, 4, 2, and I could go on all day, and really quickly I can see that this is a vertical line, not a horizontal one. Okay, so there's my lines of reflection. I guess I should really put the double arrows to show these aren't just line segments. Okay, so let's start reflecting these points then. Okay, when we're going over the y-axis, pretty straightforward. I can just see this is exactly 2 units from the y-axis. So I'm going to go straight to the y-axis, 2 units over, and I'll go 2 units out the other side, so this gets reflected right there. Okay, so this is going to be P prime after reflecting over the y-axis. And then if you look at the coordinates, it's 2 left, 3 up from the origin. So hey, when we reflected over the y-axis, the x changed. When we reflect over the x-axis, the y is going to change. Let's check it out. So I'm going to go 3 units down straight to the x-axis, and then 3 units out the other side. There we go. And then this would be the point 2, negative 3. So you see that the y has changed when we're reflecting over the x-axis. Okay? Gets a little trickier when we're going over other lines. So if you've got the line y equals x, or if you had the line y equals negative x, that would be a diagonal going the other way that you're reflecting over. What you can do, if you can see the grid, if you've got a nice neat graph and you're on graph paper, I can kind of just think about the shortest distance to this line of reflection would be this little diagonal distance right there, right? So that's like half a box diagonally. So I can just go half a box diagonally the other way, and that is going to put me right there. Now, if you've got a sloppy graph, or you're graphing this just freehand, drawing a graph on binder paper or something, that's a little tough to do. So another way you can do this is just take the xy pair when you're going over y equals x and just switch them. So instead of 2, 3, I'm going to get 3, 2. Okay? So if you were to reflect the point 9, 21 over this line, it'd be 21, 9. Okay? And if you're going over y equals x, they switch positions, and you also take the opposites of both. Okay? But you can also do the diagonal boxing if that works with the graph paper you're using. Okay? Or with your given graph. All right, and then going over x equals 4, just remember we're going over this line, not over the y-axis, right, or the x-axis or anything. So I'm thinking, okay, it's 2 units right there, so I'll just go another 2 units. There's no rule that when you're going over x equals 4 or x equals 5 or something like that with the xy pair. So you just have to see where you end up. So in this case, I ended up at 6, 3. So P prime is at 6, 3, yeah. Okay. Just putting the box around my answers here to indicate those are my final answers. Okay, Now we've got some lines of symmetry. How many, sketch them, and then how many of them are there? So a line of symmetry is a line where you can fold a figure perfectly in half, okay? So if you imagine, I'm just freehanding this, not using a ruler or anything, but if you imagine drawing a line straight down, you could fold this hexagon in half and it would match up. There wouldn't be any corners sticking out. In other words, all of these points would reflect over that line, right? Like this point would reflect right to that one and so forth. All the corners reflect to each other. So that works, okay? And so when I look what I did there, I went from the middle of a side to the middle of an opposite side. So, hey, I could also fold it like so, right? Or like so. So far, one thing you have to be careful of, some people look at this and they'll count 6 lines because they'll go 1, 2, 3, 4, 5, 6. Well, then you're double counting this line, right? So far I've drawn 1, 2, 3 lines. But wait, there's more. So you just got to kind of think through these. I don't know of any rules that you can figure out on these. You just got to think through, well, how else could I fold this? Well, if we go from corner to corner, that would actually fold in half too, right? If you think about those corners, they would match up perfectly. So these reflect onto each other, and so do these, okay? And so, yeah, we can go from any of the corners to the opposite corner. So I had 3 red lines, and now I have 3 pencil lines. So that's going to be a total of 6 lines of symmetry, okay? So some people might say, well, what about a line, and I hope you'll be able to see this, what about a line like this? I'm using a highlighter, it might be a little, well, that actually is not going to work. If you actually try cutting this figure out and folding it like that, this little corner is going to be sticking out when the corners won't match up, okay? So like this corner would end up, if you reflected it over that line, it'd be somewhere out there. It's not going to match up perfectly. So that one doesn't work. So there's just those 6. So yeah, just ignore that highlighter one, but the 3 pencil ones and the 3 red ones, okay? All right, last but not least, let's do a little factoring. So remember, factoring is breaking something up into a multiplication problem. So first thing I'm going to do is see if there's a common factor. Is there anything that goes into all 3 terms? Well, there's not. There's nothing that goes into all 3 of those terms. So assuming this is factorable, it's going to look like, which it is. It's going to look like this, okay? So I know that because if you remember FOIL, and there's going to be something in the back of those parentheses. I don't know what that is yet. But if you remember FOIL, you do first, outer, inner, last. So these would be the firsts. That would give me x squared. That's really the only way to get x squared when we're factoring trinomials like this, okay? So the trick is to figure out what goes in the back of the parentheses. A lot of different methods. I'm going to use the diamond method, okay? What I do is I take the coefficient of the x term, take the negative with this, but just the number part is the coefficient, okay? And I'm going to put that up top of my x, and then the constant, which goes at the end, is going to go down here with the sign. Pull the sign with it. Don't just write 3 and 10, okay? Now I'm looking for 2 numbers that add to negative 3. The same 2 numbers should multiply to negative 10, okay? So I'm going to start brainstorming ways that I can multiply to get negative 10. Just kind of throwing these out there. And you don't necessarily have to write these down, but you kind of want to be thinking through your options like this, okay? So there's the 4 ways using integers that I can multiply to get negative 10. I'm looking for one of those pairs that also adds up to negative 3. And there's only one that works. It's this one, okay? So it doesn't matter if you put the 2 on the right or the left, but you should have a positive 2 and a negative 5. Negative 2, positive 5 does not work. It has to be positive 2, negative 5, okay? And again, you could put the positive 2 in either of those 2 slots. So you could have these 2 factors in either order, but they have to be these 2 factors exactly. And that one is factored, and that's all I got. All right, see you next time.